Alright, so this is the unit circle. This is the lesson for today. We're just going to be filling this in. We're going to use some of the basic concepts we know, and then it's all going to kind of come together at the end. So, and we use this as a tool in math, just as a reference, and you'll use this next year for sure. So, the initial angle, turn your neighbor, what from yesterday or the last, was it yesterday's lesson or 2 days ago, what's the initial side of an angle? Where does it start if you're looking at the unit circle? Where's the initial side? Talk to your neighbor. Okay, initial side, where's your initial side? It's to the right, okay? In case you are confused, let me give you some basic. So this is like your x-axis down here, and this is your y-axis, which makes this your center, right? You all agree? So the initial side has to be here on the right-hand side, okay? This is your initial side. Okay, so this is what we're going to refer to when we're working this out. So if this is your initial side, how many degrees is it if this is the only ray? How many degrees if we don't put another ray? No, how many degrees is it? 0, right? So let's put 0 here. If I started here, guys, if I started here and went around all the way, how many degrees is it if I went around one time all the way around the circle? 360, good. Okay. Because it could either be a 0-degree angle or a 360-degree angle. They're both the same. So we have two angles here. It's just the way it is. It just represents that. Okay? If you go halfway around the circle, how many degrees is halfway around? 180. Good. Not 270. 180. Okay? If I go a quarter of the way around the circle, how many degrees is it? 90. Good. So you're writing this down with me. Okay? How many degrees is it if I go 3/4 of the way around? 270. Good. All right? All right, degrees. Now, if 1/4 way around the circle is 90 degrees, how many degrees is it if I just, went halfway to 90? 45. Good. How many degrees is it if let's say I went 1/4 of the way is 90 and I divided that quarter by 3 separate sections? How many degrees is it to go to one of the 3 sections? 30, good. How many degrees is it to get to the second section? 60. Hopefully you're following this because we're not going over this again. Okay? All right, with your neighbor, I want you to fill in just the degrees all the way around. If you know this is the pattern, you got 0. Quarter way is 90. You know that half of a quarter is 45. I want you to fill in the remainder of the spaces that are there. You could work with your neighbors or your groups now. You could talk and figure this out. I'm going to give you about a minute to write them down. Let's go around the circle together. What's this next field? What's this one supposed to be? 120. 120. Next one? Good. Next one? Good. Next one? We have that already. What? 210? Good. Next one? Good. Next one? 240? All right? Yeah, 240. Next one? And then after 270? Good. Next one? And last one? Okay, good. Okay? So, this is just our circle divided neatly into quarters or eighths or into sixths, right? Or 12ths, actually. Okay? Anyways, that's the basic stuff. Okay, now we need to think about the length of our radius. So in our unit circle, we're going to assume that our radius is 1 unit or 1 radius. So the distance from the center to the edge is the radius. Do you all agree with that? Okay, so we don't know how long the radius is exactly, but we're going to call it 1 unit. That's why we call it the unit circle. Okay, so you don't have to write this red line down or 1 unit. We just want to make this assumption right now, okay? So if this is 0, 0 in the middle, and we're trying to find the ordered pair out here, what's the ordered pair out here? If this is 0, 0, and the distance from here to here is 1 unit, what's this going to be? 1, 0. Good. Okay, so this is going to be 1, 0. Okay? If I know this is 1, 0, let's just work with the basic numbers. If I go up to the very top, what's this one going to be? What? If this is 0, 0, what's the ordered pair up here? 0, 1, good. Okay, back to the center of the origin. If I go to this ordered pair on the left, what's this ordered pair going to be? Negative 1, 0, good. What's the ordered pair at the very bottom going to be? 0, negative 1, good. Make sense? Good? Okay. Yeah, I did. Thanks. I zoomed in too quickly. 0, negative 1. Thank you. Okay, so back to geometry. This is what Miss Good taught you a few days ago. Okay, let's go back and think about our various triangles. Okay, on the left side, okay, that doesn't look right. If this is 90, and let's say this is 45, okay, that's one of our special case triangles, and then I'm going to put another special case up here. You might need to go back to your notes. At the top right, okay, turn your neighbor, describe what the sides of these should be. Okay, what should the sides of these be? Look back in your notes. Okay, 45-degree triangle, looking up here, what's one of these sides equal to? Let's call it x. If this side's x, what's the other leg? How long is it? X, good. If these two sides are x, what is the x rad 2? Good, okay? So that's from before. Now, I want to apply this to the unit circle. So this one's going to be a little bit of a harder question. So if I did this again, okay? If the unit circle, the distance from the center to any part on the circle is 1, that means our hypotenuse is 1. If our hypotenuse is 1, what's the length of each of these legs? If you know this is if this is the relationship, what's the length of each of these sides? Okay, I'm going to give you a minute to work with your neighbors to tell me what each of these are. Okay, ready? Go.
The hypotenuse is x rad 2.
Good, so this should be x rad 2, right? If 1 is supposed to be x rad 2, what's x? How do you get x by itself? Divide by rad 2. So that means x has to be equal to 1 over rad 2. Do you all agree with him? Ah, what's wrong with this? Why do you have to do that, Shelby? Good. So this denominator, do we want a radical in the denominator? So we have to rationalize it. What do we need to do to both the top and the bottom? Good. We have to multiply it by rad 2 because we have to rationalize it. So we're all doing this on the side of your papers because you need to have this. So we got rad 2 over, what's your final answer of each of these? 2. Good. So that means on each of these sides is going to be, x is going to be equal to rad 2 over 2, right? We need this information in order to do this triangle, okay? So catch up just for a moment. Give you about 10 seconds. Okay, continuing on here. We're going to do the same thing on this second special case triangle. The second special case triangle. turn your neighbor, describe what's the relationship between all of these three that you know from geometry and that we reviewed a couple days ago. Okay, I'll give you about 15 seconds. Ready, set, go. Relationship. Okay, let's start with the shortest side. What's the size of the shortest side? X, good. So then, what's the length of the hypotenuse? X rad 3 or 2x? I heard two answers. 2x, good. And what's the length of the x rad 3? Okay, good. So, this is from geometry. Now, but we don't want to assume that the hypotenuse is actually 2x. Remember, I want the hypotenuse to be 1. So if the hypotenuse is 1, with your group or with your neighbor, identify what the lengths of the remaining sides are. Ready? Go. What's the short side? That one's going to be the easier side. What's the short side going to be, everyone? If the hypotenuse is 1, what's the short side have to be? 1/2. Okay? Good. What's this side going to be then? Good. It's going to be 1/2 times rad 3, right? Do you agree with it? It's going to be 1/2 times rad 3. What's 1/2 times rad 3? Good. Rad 3 over 2. Okay? Good job. Okay. So we need this information. So I need these two triangles at least on your, the ones that are boxed. I need these two triangles on your paper. Okay? I'll give you 10 seconds to catch up here. So I need this one. And I need this one over here. Okay? So if I know this is the special case, or these are two special case triangles, and we're assuming a hypotenuse of 1, we need to know this. Because the radius is always what in my circle? What's the radius always, everyone? 1 unit, right? Okay, so you're going to notice that you're going to be able to create a triangle from any of these positions, okay? So, I'm going to show you to do one of these, and then we're going to continue on individually or in your groups. Okay, so, eyes up here. So, we're going to go back to 0, 0. Eyes up here. This is going to be conceptual now. We're going to be applying one of these special cases all the way around. Okay, so, if I go to 0, 0, and I'm going to just work on this point right here. I want to figure out what's the ordered pair for this point right here, okay? So that means I'm going to imagine, you're not writing this down yet, okay? I'm going to imagine that this is a triangle, right? Doesn't this create a triangle? This isn't straight. Let's try this again. Okay, would you agree that if I were to draw a line from here to here, this creates a triangle, right? Is it a right triangle? What kind of triangle is it? A 45, 45, 90 or a 30, 60, 90?
30, 60, 90.
Isn't it 45 degrees? Right? You all agree? Okay, not a trick question, right? So if this is 45, and this is 45, and the hypotenuse is 1, right? What's the distance from the center to, just if I wanted to get to the ordered pair up to here? What would this distance be?
Rad 2 over 2.
Good. This distance would be rad 2 over 2. What's the distance here? Rad 2 over 2. The same, right? That means our ordered pair here has to be rad 2 over 2, rad 2 over 2. So I'm going to back this up just a little bit. We're going to write, we're doing this together now, rad 2 over 2, rad 2 over 2. That's your ordered pair, right? Because we know that if we created a triangle, that would be the ordered pair to get there. Make sense?
What about the other one?
This one? Okay, let's do that one next. So, how many degrees is it to here if we were to make a triangle? Okay? So, answer carefully here. We're going to make a triangle with this red line. What's the distance from the center point to this ordered pair? 1 unit, right? So I can make a triangle here, right? And we're trying to figure out what's the distance from the center to here, to the end, and the distance from the bottom to the top here. Okay, identify with your neighbor. What kind of triangle do we have up here right now? Good. So this we all should assume is your 30 degrees, and this has to be your 90, right? Because it's a right triangle. So this has to be 60. So with your neighbor, identify what's the distance here at the bottom first, because we want to know the next one. Looking up here, we have, is it 1/2 or rad 3/2? Good. Couldn't we twist this to make it look like that, right? Okay, so our x-coordinate distance is going to be, let me erase some of this so it doesn't stay up there. It's going to be rad 3/2, and the y distance is going to be 1/2. Okay, good. Next one. I'm not going to draw the triangle. I want to see if you can get it this time. If I draw a line from the center to this 60-degree mark, working with your neighbor, figure out the ordered pairs here. Okay, it's not a trick question, but you're going to have to think about it. I want to check your understanding before we move on. So I'm going to give you about 30 seconds with your neighbor to figure it out. Go. What is our ordered pair? Good. 1/2 rad 3/2. It's not a trick question. You'll see a pattern emerging when we do this. Okay?
Bless you.
Bless you. Okay. Make sense? Thumbs up if this is making sense so far. Okay? Good. If it makes sense in here, it'll make you sense out there. Huh? Whoa. Okay, anyways. It's funny. Haha. Okay, so these are all positive. So this is, you'll start to see a pattern, right? If this was 1, 0, and then this was -1, 0, let's just talk about the 45-degree angle on the opposite side. If this was rad 2/2, positive rad 2/2, what's the opposite going to be down here? What's this order going to be? Negative rad 2/2 and negative rad 2/2. Does that make sense? Let's all write that down here. Right, because from the origin we're going to go negative rad 2/2 down negative rad 2/2. Does that make sense? Let's do the 45-degree angle up here. We're going to go negative rad 2/2. Good. Okay. So now that we're seeing a pattern, I want you to finish up all of these ordered pairs. I'm going to give you about 3 minutes with your neighbors. You already have enough information to start and go all the way around. I want all the ordered pairs. 3 minutes, okay? Ready, set, go. No, that's my worry. Okay, so let's go all the way around here. Up at the top here, what's this one, everyone? What's the ordered pair? Negative 1/2 what? Rad 3/2, not rad 2/2. Remember, rad 2/2 is for your 45-degree angles. Next one, what's this ordered pair here? Good. Okay, next one down here. Okay. Good, negative 1/2. I'm hearing some differing answers. I hope you're checking your work because these are so easy, but it's easy to make a mistake because you think it's all the same. These are not the same points, okay? Next one, down at the bottom right. Okay, 1/2. Okay, next one. Rad 2/2. Good, next one. Okay, good. Okay. Raise your hand if you got it right all the way around the first time. Good job. Give someone a high five or get a high five from someone. Okay. Well done. If you didn't get it right, just fix it. Remember this. We're using this as a tool, so I'm hoping you write this down neatly because you're going to keep this like as a little resource for you. Okay, making sense? Good, because if it makes sense in here.
Oh my god.
It's funny. I'm smart. Okay, so why does this matter?
Circle.
Okay, next thing. Why are we doing this? Okay, I'm not going to add the radians yet. We're going to do that at the very end. Eyes up here. This is conceptual. I need you to understand this right now. Everyone's focusing right up here. Okay. So why does this matter? Remember, all of these are triangles. Okay, so I'm going to go back to our first 30, 60, 90 triangle. Please end your conversations. I really need you to focus. Okay. I know that if I were to focus on this point, this creates a 30, 60, 90 triangle, right?
Yeah.
Does that make sense? We're assuming these are the ordered pairs when we have a hypotenuse of 1, because that's our radius. Make sense so far?
Yeah.
What if I didn't know this? Well, before that, let's do a little quick review. Sohcahtoa, okay, sine is equal to what? Good, thank you. Ka means what? Or cosine equals what? Good. Tangent is equal to what? Opposite over adjacent, okay? So, if I wanted to find the x value here, and I didn't know what it was, let's pretend I didn't know that it was rad 3 over 2. How would you figure that out? Would you use sine, cosine, or tangent to figure this out? If you know this one was 1, if you knew your hypotenuse was 1, what would you do to figure out this x value? The degrees is 30 degrees. If I know that the hypotenuse is 1, and I didn't know this adjacent side, how would you figure out the adjacent side? Would you use sine, cosine, or tangent? Let's pretend we don't know the other side too. We just know the hypotenuse, and we know it's 30 degrees. If I wanted to find the adjacent angle, what would you use? Sine, cosine, or tangent? Cosine, thank you. Focus. This is a conceptual thing, why we need this. Okay, so cosine of 30 would be equal to, we know cosine, it's Sohcahtoa, so it's going to be adjacent over hypotenuse. So that means the cosine of 30 is equal to our adjacent over 1. How do you find the adjacent side? What would you do? How do you find the adjacent side? How do you figure out what A is going to be equal to, the adjacent side? How would you solve for it? How do you get A by itself? What? You're getting there. How do you get A by itself? Times 1, right? So it's really just cosine of 30 times 1. What's cosine of 30 times 1? Cosine of 30, right? So let's take out your calculators. You can use your phones. Pull out your phones for today. Or if you have a calculator, that would be better. Okay? If you put 30 cosine, what do you get? 0.866, right? So, does anyone have just a regular calculator? Sometimes if you have a regular one, it'll say rad 3 over 2. Does anyone have a regular calculator that produces rad 3 over 2? Does yours do that? Good, and the answer was... Okay, let's take the square root of 3. Let's see if this is the same thing. Square root of 3 divided by 2. What do you get? Point. Isn't that the same answer as cosine 30? Right? So, we use the circle to know that the cosine of 30 is going to be rad 3 over 2. Okay? How would you figure out this opposite side? What would you do? Sine, cosine, or tangent? What would you use? Sine, right? Because we know that sine is going to be opposite over hypotenuse, right? So the sine of 30 is going to be opposite over hypotenuse. If our opposite is unknown, how would you figure out the opposite? if our hypotenuse is 1. How did you figure sine of 30 out? Times 1. So what's sine 30 times 1? Sine 30, right? Let's put sine 30. What do you get when you put sine 30 in your calculator? It's 30. What's that? 0.5 as a fraction is? 1/2. Isn't that what we have here? You see that? So the first number all the way around, the first number of your ordered pair is cosine or sine? Cosine, good. The second number is? Sine. So instead of us having to go to a calculator all the time, you start memorizing, you're like, oh, there's a relationship. So if I wanted to find the x value of a triangle on the unit circle, it's going to be the cosine. Second one's going to be sine. Does that make sense? Okay, so I want you to think about what I just said. I want ones to tell the twos. If you're on this side, you're a 1. Talk about how we produce how the first one is cosine and how the second number is sine. Okay? Twos will tell ones about how the second number is sine. Okay? 1 minute. Ready, set, go. So now we've talked about the degrees. You should all know about the degrees. That's the easy part. We should all know about all of the ordered pairs all the way around and how the first number of the ordered pair is cosine, the second one is sine. Okay? Ms. Good was talking to you about how we change. There's degrees. We can measure angles with degrees. What's the other way we can measure angles? Radians. Okay, radian just means the distance of the radius. Okay? So when I'm talking about circumference, what's the formula for circumference from geometry? R squared. What's the distance around? 2 pi r. What is it, everyone? Okay, what's circumference one more time?
2 pi r.
Good. So a radian is really just what? A radius. A radian is the same thing as a radius. So what's the distance around the whole circle again? 2 pi r. So it's like saying 2 pi radians. Does that make sense? It's the same thing. So if I were to go around the circle all the way one time, it would be 2 pi radians. So we're going to put, I have to write from down here because I'm out of battery. We're going to write 2 pi r here. If I go all the way around, what's the circumference? 2 pi r, 2 pi radians. Okay? We just wrote that right here. How many radians do I go if I don't move any way around the circle? 0 pi radians. So we're going to put 0 pi radians, okay? Above it. Just like we had 0 degrees. This position of the unit circle, it could be either 0 pi r or 2 pi r. Okay? If I know that to go all the way around the whole circle is 2 pi r, how far in radians is it to only go halfway around the circle? 1 pi r or just pi r. Okay, so on the opposite side at 180 degrees, we're going to put pi r. Okay? That means 1 pi radian. Okay, if I know to go halfway around the circle is pi r, what is 90 degrees, really? Half pi r or just pi over 2, okay? So we're going to put pi over 2 radians. Okay, if I know to go a quarter of the way around the circle is pi over 2 radians, what is halfway to a quarter? Pi over 4 radians. Good. Pi over 4. You go, Lauren. Pi over 4. She said it first, the most confidently. She's like, pi over 4. It wasn't like, okay. Good. You're doing a good job. Look up here. If I know that to go, this one's going to be a little bit weird. So, if I know to go halfway around the circle is pi over r, remember that each of these 30 degrees, how many pieces of 30 degrees is it to go around to halfway? How many? 6. So if or another way to look at it is, so how many pi radians is it to get to 30 degrees? If there's 6 of them here. Pi over 6 radians. This one's a little bit confusing. Okay, so this one's pi over 6 radians. Next one's going to be pi over 4 radians. Next one's going to be
Pi over 3.
pi over 3 radians. Okay, with this knowledge now, I'll just give a pi over 3. I want you to go all the way around, okay? And I'm going to say that there's a hint someplace of all of the pi's. We'll try to figure them out on your own, okay? I'll give you 2 minutes to do that. Like we're getting done here. I'm liking the conversation I heard. So this next one, what is this one going to be? 2 pi over 3. Good. Next one. 3 pi over 4. Good. Next one. 5 pi over 6. Next one. The one that's underneath down here. 7 pi over 6. Next one. 5 pi over 4. Next one. 4 pi over 3. Good, because you have to simplify that fraction. Next one. Bottom down here, what's this one going to be? Good. Next one. What? 5 pi over 3. Is it just going to be Lauren is talking? 5 pi over 3. Good morning. Okay, next one. 7 pi over 4. 11 pi over 6. Okay, good. 7 pi, yeah, that's a 7. Okay, where could you have seen these answers? Anyone figure out where you had all these answers?
No.
Flip it over on the back. Right? Aren't those degrees? We all know. I want you to see the connection here. 300 degrees is the same thing as 5 pi over 3. Do y'all see that? 270 degrees is the same thing as 3 pi over 2. Okay? So, last thing, we're almost done here. The first number of the ordered pair is sine, cosine, or tangent? Cosine. Second number is? Sine. So when I flip over my paper, right, if I'm looking at the sine of 0, I'm looking at the second number. What's the sine of 0? 0. So I can put a 0 here. What's the cosine of 0? 1. So we're going to put a 1 here. Does that make sense? We're only going to worry about the first 2 columns here. Okay? What about the sine of 30? Sine of 30 is? 1/2. Cosine of 30 is? Right 3 over 2. Okay? So I want you to start filling this in. And that's it. That's your lesson for today. That's all we're doing.